In this video, I will explain the species present in an acidic salt. So, salts fully dissociate. So the first equation that we're going to write will be the full dissociation of your salt. Now that will produce lots of ions, so it's going to be a great electrical conductor. What happens with acidic salts is one of the ions will undergo a further reaction with water and produce hydronium ions. Let's take a look. So any ammonium-based salt, like ammonium chloride, will initially fully dissolve into its ions. So you'll get your ammonium ions and your chloride ions. Remember, chloride ions do not react with water, and so they will sit there. The ammonium ions, however, do further react with water. They can donate their proton. And so a second equation is written, and this is a hydrolysis equation. So it's where the ammonium ions react with water. So hydrolysis is just a react with water. When they do that, they are just weak acids. So only some of the ammonium ions will donate their proton, but in doing so they'll produce ammonia and hydroniums. So in terms of listing the species present, the first thing to note is that you'll have no ammonium chloride in your list because it fully dissociates, and so it's all broken up to give you ammonium ions and chloride ions. Now none of the chloride ion reacts via hydrolysis, so the species present in the highest concentration after water will be the chloride. Ammonium ions will be closely followed, although they'll be slightly lower, as some of them, and I'm talking at very few, will undergo hydrolysis. In doing so, you will get ammonia and hydroniums. Now that should actually be an equal sign. And then your final species is the hydroxides. Don't forget that you will always have present your hydroniums and your hydroxides. So do go back and edit your notes and make sure you've got an equal sign in here, because the ammonia concentration will be equal to your hydroniums. Let's look at the graphical representation. So what we have present, and you'll note that I've not put the water bar on this graph. So again, it depends. Quite often in a question, they'll actually ask you to exclude water anyway. But the presence of the chloride ions will be almost as high as the ammoniums. These will be slightly lower because a few of them will undergo that partial dissociation. In doing so, you produce equal amounts of the ammonia and hydroniums. And don't forget the little hydroxide concentration. It will be considerably lower than the hydroniums, as this is an acidic salt. Up next, I'll discuss the basic salts.